Hi everyone, this is Sam Gabriel. Welcome to another video. And in today's video, we're going to talk about a new project that I'm working on. And really, it's going to be a series of videos that I'll put together covering a topic of end-to-end infrastructure and application deployment. How do we use CI/CD tools to automate the whole process of building infrastructure, provisioning infrastructure, and then deploying the applications onto this infrastructure, how this ties into the different personas in an organization, what do the admins do in a DevOps team, in a cloud delivery or cloud excellence team, how does all that tie together to deliver quick and fast application deployment in an organization to adopt agile methods. So to be able to get notified with all the new videos that will come out, please subscribe to the channel and also hit that bell button to be able to, again, be notified whenever a new video comes out in this series. And let's go ahead and get started, and I'll show you what exactly what we'll be doing in this series. Okay, so end-to-end infrastructure and application deployment. Now, I'm going to break this up into 4 sections, maybe 5, we'll see. But basically, in the very beginning, we want to be able to build a secure CI/CD pipeline. And in the process, we're going to touch on a bunch of tools, some from HashiCorp, such as Vault, Console, and Terraform. We'll also be working with Jenkins for our CI/CD pipelines. We'll also work with GitHub for our version control system, and Azure will be our cloud of choice for this project. And Ansible also will be used as a configuration management tool. So as you can see, we're going to tie in all these tools together to build a robust and secure CI/CD pipeline to not only deploy infrastructure, but also deploy the applications as well. I'll try as much as possible to introduce best practices as we go through this and see how the integration works between these different tools. And we got to start somewhere, so we'll start with Vault Azure Secrets Engine, which is the topic of this video. And just a sneak peek, you'll see that we're going to set up Jenkins in the next one. And then we're going to find a way to introduce secrets into Vault, or we call this the Vault Secure Introduction. Really, what I mean is securing Jenkins and introducing the Vault token into Jenkins in a secure way. So kind of solving the secret zero problem. And then finally, we're going to take a look at how everything comes together, building the CI/CD pipeline I talked about earlier. So let's get going and go ahead and take a look at the agenda for today. So we went through the brief introduction. The overall goal, we kind of touched on that a bit, but I'll get into a little bit more detail. And then some of the topics that we'll learn in this series of videos. Then we're going to get into a diagram to show how the Vault Azure Secrets Engine works. Then we'll get into a demo, and I'll wrap up with a conclusion for this video. Okay, overall goal. This is a very busy slide, I know, but just to show you the different pieces that we'll talk about, they kind of have the same color codes that we saw in the very beginning. The first piece here is, let's say an admin, a Vault admin or a DevOps admin, needs to configure Vault to have the Azure Secrets Engine configured. And that basically sets us up for the ability to use that Secrets Engine to embed Vault secrets for the Azure credentials into really Terraform moving forward, as you can see in multiple locations. So that way we securely can dynamically get the Azure secrets that are needed to provision resources inside of Azure, as opposed to giving static secrets to developers or DevOps teams. This is done securely with a time to live, so that once, let's say every day you get a new set of credentials to access Azure, you can put these into Terraform, for example, and then at the end of the day they disappear. So there's a number of use cases. We'll touch on that in just a bit. The box in blue here, this is the topic of our next video, to see how we can create a Packer image inside of Azure, then use Terraform to deploy this image. And really the content of this image is just a simple VM running Docker. And then we'll see how Ansible is going to run the Docker container that is hosting Jenkins. Inside that container, we're also going to have the binary for Vault, for Terraform, and also Ansible will be in there as well, so that Jenkins becomes the brains of our operation. It's going to be our CI/CD tool for all our pipelines. So it's going to call on Terraform. That's the topic of our fourth video, really. It's going to be able to talk to Terraform. It's going to talk to Ansible. It's going to retrieve secrets from Vault. So all that will be done to create the infrastructure to finally deploy the application or applications that we want inside of Azure. Now, the topic of the third video I skipped over. Basically, we need to find a way to get the Jenkins VM or the Jenkins container to get the Vault token to be able to authenticate into Vault and grab secrets pertaining to the application or secrets pertaining to the Azure credentials that Jenkins later will inject into Terraform. So this is the secret zero problem that we'll talk about in video number 3. So find a way to securely get the token, the Vault token, for Jenkins to log into Vault. All right, so let's get going and take a look at the topics that we'll learn throughout this series. The first one is the subject of today's video, Vault Azure Secrets Engine. We're going to learn about Packer, how to create images, Packer images inside of Azure, how to build a VM or VMs using Terraform, and also based on the Packer image that we just created in Azure. How to use Ansible for configuration management to configure an Azure VM that was created via Terraform. We'll talk about best practices here, where to use Ansible, when to use Terraform, how we can use them together to get the best of both worlds when we're talking about infrastructure as code. And then we'll learn about Vault's secure introduction, how to use Vault app role, and creating an advanced CI/CD pipeline and the workflow pertaining to that. And in the process, we're going to use GitHub for a version control system. We're going to use Jenkins as our CI/CD tool, Terraform for infrastructure as code, Ansible for configuration management, and Vault for secrets management. Then we got, we're going to touch on the application itself. If you followed along some of my earlier videos, we had a series I called the Weblog app series, and we took a Python Flask application that talks to a Mongo database, and we walked through the process of how to learn the different HashiCorp tools using that application. So I'm going to reuse that application in this video series as well. And if you have followed along, you would have already learned about Vault Dynamic Database Secrets for MongoDB. Again, we'll touch on that as well in this series. The Vault Transit Secrets Engine, which is encryption as a service that Vault offers, that we'll also use in this application to securely encrypt our database tables for the content of our blog posts. And console service mesh, how we're going to have our Python Flask app talk to the Mongo database using console's service mesh. All right, let's talk about Vault Azure Secrets Engine right now. And I'm going to draw a diagram to show you how it all works before we get into a demo. So it all starts with a Vault admin that needs to do some configuration work on Vault. So what the Vault admin needs to do is 3 things really. First, he or she needs to enable the Azure Secrets Engine inside of Vault, then configure it, and then finally create what we call a Vault role. Now this can be done through the CLI, through the API, and my favorite way of doing it is through Terraform, as you might have seen in previous videos. So we're going to use the Vault Terraform provider. And then once this is all configured, well, now we need as an application itself, or as a DevOps operator that needs to access Azure, they'll need to talk to Vault and retrieve the Azure credential. So I'm going to make a request as an application or as a human saying, hey, I need access to Azure. Please give me some credentials. What will happen is Vault is going to go inside of Azure and create a client ID and a client secret for you. So those credentials will get created inside of Azure by Vault, because Vault has a connection into Azure through the Secrets Engine. And then it's going to return those credentials back to the user or to the application. And this will be with a time to live, right? So you can put anything like 5 seconds, 10 seconds to an hour to 24 hours. Really, it depends on what you want to do. For our use case today, I'm going to use 24 hours. I think it's a reasonable time frame. And the use case there is that sometimes third-party vendors or maybe contractors that you want to onboard to use Azure and to be able to provision things inside of Azure, or do things inside of Azure. So the best way to do that is to use the Vault Secrets Engine inside of Azure, because now you're limiting them to this 24-hour period where those credentials will eventually expire, and Vault will go back into Azure, delete those credentials, so that contractor, that vendor will no longer have access. So the idea is they're created dynamically and they disappear as well. Every morning, the user that needs access to Azure would log in to Vault, grab those credentials for Azure, and inject them, let's say, into Terraform to provision resources inside of Azure. So that's the overall workflow. Now let's go ahead and look at a demo. All right, so this is the Vault screen, and in the UI, as you can see, I'm in the Secrets Engine tab. I have a bunch of Secrets Engines here that I've used for various demos, but the Azure Secrets Engine is not enabled yet. I'm going to pivot over to the Azure portal and show you that my resource group, SAMG Jenkins, is not created yet. As you can see, no results found for SAMG. And then what I'll do is let's go over to our Visual Studio Code window. And here, before I uncomment this, let me show you what's going on here. So I have the Terraform Vault configuration folder. Inside this folder, I got a variables.tf file and a main.tf file. If you recall, we've used this a while ago. So Vault is already up and running. This is actually running in Google's cloud in GCP, in GKE. If you remember, a while back we walked through this. But basically, in here, all I'm doing is I'm adding an Azure provider. And you'll see why in just a minute. And as you can see, the Vault provider is already here. In the Azure provider, I am configuring the subscription ID, the client ID, the client secret, the tenant ID, all these as variables that are defined in the variables.tf file. So they're instantiated here. As you can see, there's also a prefix and a location. So the prefix is SAMG. That's just to find my resources inside of Azure later. Central US is the location that we're going to deploy into. So if we go back to the main file, that's pretty much it in terms of the setup with Azure. So here in this file, there's a lot of things that we're creating, policies for previous videos and previous demos. So don't worry about that for now. But our concern here is to start looking at our configuration to enable, configure the Azure Secrets Engine. So what I'll do is I'm going to uncomment this and deploy it, and then I'll come back and walk you through this code. So let's save that. And my workspace in Terraform Cloud is hooked up to GitHub here, to this repo. So what I'm going to do is I'm going to enable this. Let's say enable Azure Secrets Engine. So let's commit this. And then we're going to push this over to GitHub. And once again, the version control system connection or workflow is going to kick in. And this will trigger a plan inside of Terraform Cloud that will eventually provision the Vault server to have the Azure Secrets Engine created. Okay, so that got pushed, and let's go over to let's just wait until it actually finishes. Okay, so if we go inside of our workspace, the infrastructure GCP Terraform Vault configuration workspace, you can see a number of variables that are here. Now, just to let you know, there are some variables here that are not really pertaining to this conversation that we have today. So database user, for example, password URL, database URL for Nomad, these were from previous videos. So best practice is actually to separate the workspaces depending on what you want to do. Here, just for demo purposes, I'm kind of putting everything inside one workspace, but you don't want to have your application deployment sitting in the same workspace as your infrastructure deployment, right? So you want to separate those. So you typically have a workspace just for your application, so you can hear the secrets for, or the credentials for the database, the MongoDB that will be created inside of Vault. So you want to separate that out from the rest of the deployment. Of course, the environment variables needed here is the Vault address. So here's my address for Vault, and also the Vault token to be used to access Vault. Okay, so it should be running by now. Let's take a look at the runs. Yeah, so here's our run. So plan finished. So three things to add: 0 to change, 0 to destroy. We're going to go ahead and confirm this. Okay, so the apply is going to run. In the meantime, let's go back to our code and walk you through it. All right, so here you can see that the resource that we're calling upon here is called a resource group, which you're probably familiar with. Basically, we're creating a resource group, and I'm calling it samg-jenkins here. So that prefix I showed earlier, again, to be able to find it. And the reason why we're creating a resource group is we're going to call upon it later on at the bottom here, you'll see. So Azure creates a resource group. That's perfect. And then now we have a resource inside of Vault that we're creating called the Azure Secrets Backend. This is enabling the Azure Secrets Backend in addition to configuring it with the credentials that it needs to talk to Azure. Remember in the slide I showed that Vault needs to talk to Azure to be able to create secrets on demand when a user or an application wants to retrieve secrets from Azure, right? So here you give it the subscription ID, the tenant ID, a client secret, and a client ID. And this is based on a service principal inside of Azure that you can create. And I'll reference some documentation around that as well in the description of this video. Okay, then the next resource is creating a Vault role, and we're going to call it Jenkins in this case. The role is called Jenkins. It references the secret backend resource that we just seen before, I just created. Here's the TTL, the time to live, that we will specify for creation of credentials. So it's going to be 24 hours. The maximum TTL is 48 hours. It could be a week or a bit longer. But basically, this means that you can renew this TTL up to 48 hours max. After that, you have to create, new credentials have to be issued. Then inside this resource as well, here's where we define the Azure role. So give it a name, contributor, and give it a scope. And in the scope, you have to specify the subscription and also the resource group that these credentials will be tied to. And that's why we created a resource group up here inside of Azure, meaning that when someone is issued credentials for Azure, they're issued against this particular resource group that was created. So they can do things within that resource group itself only. Okay, so that's pretty much it. This is how you do it through the Terraform Vault provider. And also there's, of course, like I mentioned earlier, you can do it through an API or through the CLI commands as well. Okay, perfect. Now let's go back and take a look at our deployment. So the apply finished, it's successful. All right, let's go back to Vault and let's go back to our secrets engine. And there it is. So the Azure Secrets Engine has already been created. Perfect. Let's go into Azure just to take a look. So just type here SAMG, and there you go. Here's the resource group called SAMG Jenkins. Perfect. Okay, so now the next step is to go into my terminal and issue a command to retrieve the Azure secrets, right? So how do we do that? First of all, I need to export my Vault address here. So let me grab that from here. And then let me log into Vault. Vault login. Okay, I need a token. I can grab it from here. Just to keep it simple, I'm just using the root token. Definitely not best practice, so don't do that. Root token usually needs to get revoked once you've set up Vault and created some authentication methods. But for this case, I'm just going to use the root token as a demo. Check my Vault status. Okay, everything's good. Clear that. And then I have a command here, vault read. This command here, vault read Azure Creds Jenkins, right? So this is what's going to create my credentials inside of Azure. I'm not sure why it's stuck here. It's kind of frozen. All right, let's open a new tab. Let's try this again. Okay, so let's export our Vault address again. And log into Vault. Okay, let's just try to grab this. Okay, I think I have it here in my README file, so I'm just gonna grab it from here. So once again, this is talking to Vault and asking for the credentials that we want to as part of this specific role, this Jenkins role. Okay, so as you can see here, this is the lease ID. This is important if you want to revoke this particular lease or those credentials. You can use that in the revoke command, or if you want to renew it. Remember, there was a maximum TTL of 48 hours, so you can still renew as long as you're within those 48 hours. So leasable renewable is true. 24 hours is the duration of our lease. And then this is what you're going to use, client ID and client secret, to log into Vault Azure, or to do things inside of Azure, basically. So you're going to need those credentials for that. And in a later video, in the next video, actually, we're going to use those credentials inside of Terraform to be able to do some configuration or provisioning inside of Azure. Once again, this could be tied to an application. Application automatically gets these secrets. That's what we'll see with Jenkins later. Or it could be for humans, for maybe a DevOps engineer that needs to go in, use those secrets for the day, do something in Azure, and then after that, those secrets will dynamically get created and dynamically get revoked and removed as well. So you don't have to worry about static secrets to be used and compromised and so on. So hopefully this has been helpful to get an understanding of how to create the Vault Azure Secrets Engine, and also how to retrieve secrets dynamically from Azure using Vault. And again, this is the first video in this new project to look at end-to-end deployment for infrastructure and applications, and see how we can tie all these tools together in a secure manner to create secure CI/CD pipelines. Thank you for watching.